Hi, I'm Bastian. Actually, I'm the other Bastian, because there are two, and both are speaking about Kubernetes a little bit, and it's like very confusing. So we were among the speakers chatting this morning, and I was like, hey, that talk is so cool, and somebody was like, how can Bastian speak and type at the same time? So it was very confusing. I'm a system engineer at Amazee.io. We do containers in production. Who else does run workloads, like real production workloads on containers? Yeah, it's a small crowd. Yeah, I live in Zurich, so I took a train for 5 hours and now I'm here. You can find me on Twitter at @dasrecht, and I'm a person with not enough sleep and too many side projects. So I help organizing TEDxBurn, I help organizing the DevOps Days Zurich, and a lot of other things. Among those things, I also run Tor exit notes for fun and profit, and it's very wonderful. If you want to talk to the police, that's the perfect way to do it. So who knows, or who really knows what containers are? Okay, sorry, you're wrong, because this is a container, and this is how a deployment looks like. So, sorry for that. What will we talk about today? So we will talk about serverless, we will talk about concepts, we will talk about containers, obviously, we will talk about infrastructure, modern software architecture. So I need to take you a little bit back in time. So when I had my first web project, it was basically the website of my school. So everything I needed was an editor, a floppy drive, a FTP client, a server, and a browser. And the world belonged to me. I could set something online, and everybody else could see it. And it was fantastic. Like the first time I basically pushed the website online, it was like, oh my god, that's the world. I want to work in that field. So I started working in that field, and lately it became very, very interesting. So today we have all those new technologies. Suddenly containers are on the rise. We talk all about microservices. Security is a big thing, and I'm an operations guy, so I see a lot of companies struggling that operations can keep track with the speed of technology change these days. So it all boils down to a lot of complexity. Who feels the same? Like overwhelmed by all the technology changes? Be honest. Yes, thank you. So I had the feeling like, oh, that's going to be very complex. I mean, when I look at what we do, we are a Drupal web hoster. And when I see that a standard Drupal site needs the knowledge of how to run Composer, and then people just deploy it on the server and they say, oh, it doesn't work. Like, have you run Composer? And it's like, oh yeah, that thing. So there is a lot of knowledge to build up on how to do modern architecture. And my goal is basically to give web development the heartwarming moments back that I had when I started, but with all the new tools. Like if you want to run a decoupled site, you can do that. If you want to use Composer and containers and do whatever you want, you can do that. And that's the platform I'm currently building with my team. So to give you more context about where we started, I take a quote from 2012 from one of my colleagues. And it was that time when we had automated setup of servers, but everything was very static. And if you wanted something, there's somebody at the door. If you wanted something, you needed to talk to operations, and it took a week till we got everything set up because we were very busy. And at some point he said, wouldn't it be really cool when we just, like, we have everything in Git, and if we could just, like, define, I want a MySQL server in this version, and I want Apache or Nginx in this version, and just throw it against the service and it will spin it up. And I was like, okay, hold the horses. That's fun, but we're not there yet. We're dealing with a lot of other problems. So a little bit later, I changed jobs, and basically the first project was doing a full rebuild of the infrastructure we had. We did everything in configuration management. It was still servers, and the rebuilded infrastructure gave us per commit deployments. If you committed something and that was linked to an environment, it was deployed. And because, like, we wanted to go the full length, we also had the local development environment set up in with the same tools, and it was based on Vagrant. A year later, we saw, hey, this is cool, but not flexible enough. VMs use a lot of space, and that Docker thing came around. And we were saying, like, yeah, let's give Docker a try. Let's try our containers. Because it wasn't just working out of the box, we needed to build some tools around it to make it more developer-friendly. And that's one tool that's open source. It's called Pygmy. And it basically helps you setting up a few containers, and it makes the experience for the developer much easier. And at some point we were there, and we had a team meeting, and there was one question brought up. Why are we containers? Why are we just using them locally? That was basically the turn point where we decided to just go out to one of our customers and ask, hey, we know that containers run perfectly well locally, but we could, we could do that basically for your website online. And you shouldn't, if you want to do that, don't take your biggest customer, maybe take a mid-sized customer. That's just an advice. And we did that. And at some point we said, hey, this works. This is fantastic. And this step allowed us to basically have pull request environments. So somebody opened a pull request, and it created a new environment, completely containerized on our platform. You could test it, and if it's nice and it's approved, you just merge it in and it deploys it to production. We then were sitting together again, a few beers down, and we were discussing about we should do more open source. And then our CTO came up and said, hey, we could actually open source our platform. And the team was like, are you crazy? Nobody does that. He's like, yeah, just because of that, let's open source Lagoon. This year, we're currently migrating all our customers from the legacy system to Lagoon. We're not on version 1.0 yet, but where's the fun? So we're currently working on the 1.0 version, but we see that it's already enough to host our customers. So you ask, what's Lagoon? Lagoon is the 4th iteration of the hosting stack we run, and it's fully open sourced, so you can go to github.com/amazio/Lagoon, download it, start Kubernetes cluster and everything, and you have a Lagoon, and you can deploy applications into it. It runs on top of Kubernetes and OpenShift, because we believe that those two tools give us the most flexibility in what we need to do. It's completely microservice architecture, and it's basically said from a developer's perspective, it's a deployment pipeline for your web projects. And, of course, it comes with a local development environment which has the same settings and configurations as you have in production. And the whole infrastructure is defined in code. So actually, it took me a few years to fulfill the dream of one of the developers I worked back in the day, and it's like, now we can't just add a Redis server. So how does it work? Basically, you have a Git repository that says, hey, I just got a new commit. You throw it against Lagoon, it's a webhook, and we do the whole thing. If you need more information, it's basically all defined in a Docker Compose file, and we roll that out. And when you push it, it can be on any Git repository that can basically talk to us. And if you do that, it goes out and reads the Docker Compose YAML. There, we find out what needs to be spun up, and then we just start that on OpenShift. And in the end, you get a message in Rocket Chat, or an email, or a Slack message. More details? Sure. That's microservice architecture. And that's where basically I can tell the person that's not here that should take the time that I will go overtime. So let's start here. No. It's like, that's just like the whole setup we have internally. When you say, this is cool, I want to do this, a small word of wisdom from one guy that just runs an orchestrated system. If you don't master, and I mean really, really master, the traditional architecture and infrastructure, you will have a hard time. Because as soon as you run containers in an orchestrated manner, it basically becomes a living thing. So now you know, okay, my problem is existing on Web Server 3 all the times. When you have orchestrated systems, your problem will exist everywhere, suddenly. And it will move around. So you need to really know what you do. And you still need skilled people. I've got told a lot of times, like, oh, this thing that makes all, like, the IT ops guys, we don't need you anymore. And I always tell them, like, okay, let's go on a construction site. We have a robot that pulls up a wall. It still needs an architect that says the wall needs to be here to the robot, because if the wall is on the wrong side, the building is going to collapse. And that's basically what I say all the time. It's still the job or the way we work, it changes. We just need to go with the change. And you don't get rid of servers. So that's all fun and games, and I always said, like, don't trust the vendor, and suddenly I'm part of a company that has an open source product and basically also sells services. You can run Kubernetes on any platform, and that's basically also what Bastian said in the morning. You can go to any big vendor and get Kubernetes. And Kubernetes actually has become the standard of running orchestrated containers. And I make an emphasis on saying containers. I don't say Docker, because Docker is basically an open standard, and I believe like 6-12 months down the road, we will have systems that are not just completely Docker. It could be that some other company just re-implements the open standard and we can start containers with something else. Plus, what we will now talk about is there is also a way to have functions as a service in Kubernetes. So there are like 3-4 big tools that can do that. But you're here for serverless, so let's talk serverless. Spoiler alert, you don't get rid of servers. You just need to change your mindsets. And the hard truth, you might not go all serverless right now. Unless you can do one of those things. Either you go in and pull a full rebuild of your application, or you're such a lucky guy or person that can just have a stateless service, or who knows the 12-factor app? Yes. Or your application is following the 12 factors. If you don't know the 12-factor app, 12factor.net, it's very cool. It's very cool. It's basically a methodology that tells you how to build modern software in a way that you can scale it, that you can just port it to other systems and do whatever you want. But anyhow, what's serverless? And there are a lot of descriptions what serverless is, and that one is, from my point of view, the best one. It's a solution that doesn't cost you anything if nobody is using it except the data you store. May that be in a database, in an object storage like images or assets, stuff like that. And serverless is that thing where the lines are very blurred. So I usually have two things I talk about. First, functions as a service, and second, serverless. So functions as a service is a concept where you write code in whatever language you want, and you deploy that code onto one of those functions as a service providers. And then you have an event-based execution. And this event-based execution is usually stateless. So you call it, it does something, it gives something back, it dies. It doesn't have a state. Though it can talk to backend services. But that's then something else. Those services or those functions are short-lived. They run milliseconds to, let's say, 5 minutes. Amazon does, like, they have a set limit to 5 minutes. If it runs longer than that, they just kill it, because something is wrong. It's not supposed to live more than 5 minutes. And you pay per use. If you use it one time, you just pay one small fee. If you use it 10 million times, you have a big fee. And you don't need to care about the compute. They just manage the load you bring. Most of the cloud vendors have setups that basically lock you in. So it's not really portable, and that's why I'm thinking that the way of OpenFAS, Rocket, and other functions as a service tools on top of Kubernetes are better, because you can just port it between different Kubernetes clusters. So what can we do with those functions as a service? For example, what we do, we have a deploy script, and when it's finished, it sends the deploy log to an endpoint, and the endpoint saves it in object storage and gives back a link. That then goes to Slack. Or somebody is calling our emergency phone number, and the service gives back an XML, which is understood by Twilio, and it says, like, hello, you're at the emergency phone number, we can reach somebody. So that's all, like, it doesn't cost me anything when I'm not using it, it's just invoked when it's used. Or an example of this morning is, if you leave your stove on for too long, your stove could send you an SMS that you still have the stove on, something like that. Or you finish the workout and your wristband just sends the data of, like, your daily walks up to an API, which then saves it in storage. So it can be anything. It's usually just event sources that then go to containers, which are scheduled somewhere, or they go to an AWS Lambda, or whichever function as a service provider there is. And then you have backend services, because you usually want to save some state. So you have message queues, or databases, or an object storage, or whatever. Let's talk about serverless. Serverless is kinda the functions as a service, but it's a little bit enriched. It scales on demand. It scales down to 0 if you don't need it. And you don't need to worry about the scaling. You don't need to worry about how much CPU cycles will I use, how much memory does it use. It's just done in the background. And one thing that we learned early on is, when you want to do or change things and do serverless architecture, you need to change and start to embrace those third-party services. And the whole things start to get loosely coupled. So you have several components in your web application, and the idea is that you can basically swap one out and put one other in, because you know exactly what this small component is doing, or this small function. There we go. So when I tell or say loose coupling, I mean also decoupling. Who does decoupled CMSs, stuff like that, like Node.js frontends? Okay, one, that's good. So the customer I talked about earlier is a big newspaper, and they have several newspapers. So they came to us and said, okay, we have one big content management system, and we want to have this sending out all the newspaper informations we have. So actually it looks like this. We have 7, in the real world, 7 different newspapers, which are just Node.js applications talking to an API to the backend, which is a content management system. So the front end is actually stateless. If you swap out the containers or start the functions new, nothing happens. The only thing it does, it talks back to an API and serves HTML. So we have a stateless front end because we scale them automatically. If there's not a lot of demand, we just start to lower the containers that run and serve the content, and if there's more demand, we just scale them up. If a newspaper ever reaches the point where you don't have traffic, you have another problem, but we would then just stop the container and the first request will just start it again. So, are we really serverless with that approach? No. As soon as you have traditional applications, monolith, you will not be automatically serverless. And as I said earlier, it's very hard to go serverless because usually we are not on the green field and we can just start something from scratch. So we just started to pull it apart, and I call this serverless-ish because we have parts that are already, we don't care about what it, like where it's run or like how much CPU it uses, it just scales with us. But on the other hand, we have that monolith that still has that still like needs the stateful approach. But there are no running costs. For example, in development environments, when there is no traffic, they just stop, including the whole backend system. So we also stop the database. And if there's traffic, they will just spin up again. So we got that nailed down pretty good, but it's really hard to get to that point. And that's where I said, like, I want to give with the tooling we build the possibility for people to just use those technologies. So let's talk a little about the future. Because I see a lot of people always saying like, oh, this is so cool, I also want to do that, but we are stuck with XYZ, with traditional infrastructure. And what I say usually is, if you're going into the cloud, it's not just spinning up the same server you had before again. It's not a one-time thing. If you're building for the cloud, you need to change a lot of your approaches. And one thing is, don't get attached to your infrastructure. Don't give your servers names. Never. Seriously, don't. Why? Who has heard of the cattle and pets metaphor? Yes. Okay. So, pets. Some people have cats. I heard there is a tweet going on about people loving cats and people loving dogs, and we should vote on it, so I'm not taking a stance here. Cats versus Petal is that pets or pet servers are manually built. Sometimes they have names like Web Server 1 or Web Server or Billing. Billing is my favorite because I built a server called Billing. Don't. And they're managed with care because they need to work, and the billing server needs to work the end of the month. So that's very hard. And if they fail, people are sad. Think about it like a pet server is like your coffee machine in the office. When it breaks down, you're going to have a hard day. Cattle, or a herd on the other hand, is built with automation. It's called Web Server 1, 2, 3. It doesn't really matter. You don't care. We actually don't even have names anymore. It's just a random string Amazon gives us. It's a little bit hard to get into that feeling because you look at something and say, this does not make sense to me, but that IP address is making problems, and you just shut it down. And the system takes care of itself and restarts and gets back to that state. And what I try to say, if you reach the state where you just have infrastructure or code and systems that you can just kill the problem and it gets replaced automatically by something that's working, that's fantastic. So another thing is the monitoring. Like, we are running functions. Do we really monitor functions? No, we don't really. Because if I don't use a function, I don't want to pay for it, and it will probably also not work at that point. So what we monitor is the usage pattern. We have a set of boundaries where we say, okay, it needs to be finished within 2 minutes tops, and we have a monitoring on that. And if we see that we have more load, that's fine, and you can see, like, is your application behaving in those boundaries? It's like a SpaceX rocket start. They say all values are nominal, and that basically means it's between the minimum and the maximum the rocket is built for. If it goes over or under it, it's usually a bad thing. So that's basically what we do. We monitor for out-of-band errors, where we see anomalies. Another company I know, they do negative uptime. So as soon as a function starts, they start to count back. Like they say, okay, it should not run more than 5 minutes, basically what Amazon does. And if it runs more than 5 minutes, it gets an alert or gets killed and restarted. So there are a lot of things that change, and you need to change the behavior, how we approach things. Because 99.999% uptime is not a thing anymore as soon as we have functions. So let me conclude with a few takeaways, and that's basically the photo slide at the end where everybody takes a picture. So what I say is go out, automate, experiment, fail, because there's a lot of failing involved in learning something, and share what you learned, because only that way we can grow. And serverless is actually just an approach to how we build modern infrastructures. We just start to use other services and just start to trust those other services. Don't get attached to your infrastructure, because if you do, you will not get over that step. And make small steps. We just started pulling parts or things apart that don't hurt us if they fail. It's like some small thing, and if we see, oh, that's not working, then we find a solution until we see, hey, that's so good, and we have so much knowledge on how to run these things, we can now use it for something that's more production critical. And build up on open source. I mean, we all use open source on a daily basis, but that's the thing like I learned when we open sourced our tooling is be the shoulder of a giant somebody can stand on, and give your things that you build also back to the community. That's the only way we can grow together. And work towards the 12-factor apps. It's hard, it's very hard, but that's the only way we can, or you can reach a level where you can say we can scale it and do crazy things. Thank you.